Hi, this is Chong Kim, and we're going to do Tic Tac Toe in Ruby using Gosu as the user interface. So let's start. So let's start with creating a gem file, and we're going to include Gosu along with the others, the RSpec and guard. Okay, we're going to run bundle so we fetch everything that we need, and we're going to initialize guard and run guard. Okay, split the window so that we'll use this part to write our code. And we need to create a lib directory and a spec lib. And we're going to start by writing our test, position spec. We're going to require position, which we haven't written yet, and we're going to describe position. The board should look like dashes, and 9 of those dashes. So to show you what that looks like, %W of a dash looks like this, and if I multiply it by 9, it looks like that. So this is our data structure. All right. So the turn should be X's turn. All right. So we save, and we get an error, and it says cannot load such file. So let's create the file and create the class position. So it'll say that no method error board. So let's create the board and turn, and initialize it. So the board is going to be dashes, and we're going to have size number of them. And size is going to be a constant, which is dimension times dimension. Dimension being 3. And turn is going to be X. All right, so it passed. So we're going to modify the constructor so that it takes an argument. So it's going to take in a board and a turn. Okay. Oh, and if you have any questions about what I'm doing, you can leave a comment or send me email, and I may respond to you or even make a video of any suggestions. Okay, so new board turn. So let's see, we need to create a position X, and we're going to need 8 dashes, and it's O's turn. Okay, so its board should look like it with 8 dashes, and turn should be O. Okay, wrong number of arguments. All right, so let's put in some arguments here. So the board is going to default to a nil, and the turn is going to default to X. So I'm setting board to nil instead of putting this on top over here, because I don't like to have complicated expressions in the argument as defaults. So I'm just going to do it this way. So this is just another way of doing it. And so turn is going to be turn. Okay, so it passed, and I save again, and everything passes. The next thing is move. I should be able to make a move. So I take a position, a new position, and I make a move. So when I make a move, it should look just like this. So, all right. So I make a move on 0. So here's the X move, and the turn has changed. So def move, and it's expecting to. It takes in an index, and it's expecting to return a position. So let's just make a position and return it. Okay, so now we get a different error. All right, so what we're going to do is we're going to make a copy of the position. So we're going to say board.dupe. We need to make a duplicate of the board. If we don't do a dupe, it'll be referencing the same board, and we don't want that. And for the turn, we're going to create a function called xTurn. So if it's X's turn, it's going to return an O, otherwise an X. So it just switches turns. And position.board, we're going to update the board now. So the index position is going to be whoever's turn it was. So now for the X turn, we have X and an O value. So if the turn happens to be x, then we want to return the x value, otherwise the O value. All right, so it passes. Okay, so now we're able to make a move. And next is possible moves. So we start off with a new position. We make a move on 0 and make another move on 1. So we should expect that the possible moves should be 0 through 8, but minus the O and 1. So that should be 2, 3, 4, 5, 6, 7, and 8. Okay, and it should have an error because undefined method. So possible moves, and let's just throw in the board here. Okay, so what we want to do is we want to convert the board into these set of numbers. So we can do that with map with index, and that'll give us the index positions. So that will give the piece and the position. So let's just put the position. Okay, so this is getting close, but we only want to show the position if the piece is a dash, if it's empty, if it's an empty position. So we're almost there, except we have these nils, and we need to get rid of the nils, and we can do that by saying compact. All right, passed. And everything else passes, good. So now we have possible moves, and we need to check if anybody has 1. So win. And okay, so let's, if you have a new position, and we're checking for a win, that's expected to be false. Okay, and let's create the function win based on the turn. Okay, so we'll just leave it empty for now. If it's empty, it'll return nil, and nil is evaluated to false. Okay, so we're going to create a little template here for the 8 possible situations. So 2, 3, 1, 2, 3, 1, 2, 3. Okay, so we have okay, a new position, and we want to check if it's a win for x. And this is expected to be true. Okay, all right, great. So let's make 4 copies of these, and just to make things a little bit different, let's change this x to an O, so we also handle the O case as well. So these first 3 are going to be testing the rows, and next we're going to be check the columns and the diagonals. All right, so let's do that. So so this will be x, 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 and okay. So now we handle the first row, second row, third row, first column, second column, third column. Okay, now we do the diagonal. So this, oops. So this is 8 cases. So we save, and we should see save everything, and failure, expected true, got nil. Okay, so it's actually stuck on the first one. Okay, so we can start from here. Okay, let's make that pass. So rows. Let's take the board and break it up into chunks of the dimension, and we need to convert into an array. We need to do this because each slice returns in numerator, and so we need to convert into an array. And given the rows, we want to see if any of these conditions are true, that given a row, if all of them are equal to the turn, so whatever we're looking for. Okay, so that passed. And we should see 5 failures now. So we started with 8, now we have 5. Now we need to test the columns. And there's a quick way to test the columns by just taking the list of rows and transposing it. So when we transpose, what we end up is a list of columns. Okay, so now from 5 we went down to 2. And we need to just handle the diagonals now. For the diagonals, we can start with the rows, and we need to do a map with index because we need to have the index information for this one. And we want to make sure that all these conditions match. Okay, so given a row and the index position, you want to see if that's equal to the turn. Okay, so this would handle the major diagonal. Undefined method, okay, I misspelled it. I need an N. Okay. All right. Undefined local variable method I. Oh, that's because I need to include the I over here because I did with index. Okay, so now we went down from 2 to 1. So now we need to handle the minor diagonal going in the other direction. So it's basically the same except the I is going to be going in the opposite direction. So we subtract it from dim minus 1. And this should go in the other direction. Okay, so this passes and everything else passes, and now win is taken care of. So we need to take care of our next function, which is Minimax. Okay, so we can start this by looking at the base case. So let's see. So if we have a win here like XXX, and x's turn dot minimax, we should expect that. Let me see if I have this right. So position minimax expect. Okay, we have a little bit too many. Okay, there we go. We expect this to equal 100. So we're just setting an arbitrary value here. So let's just say minimax, set it to 100. All right, it passed and everything else passed. Okay, so now we should check for O's. So it's O's turn. And instead of 100, it'll be negative 100. All right, so let's change the code. So now we can say return 100 if it's a win for X. Return negative 100 if it's a win for O. Okay, there's one more base case, which is if everything is completely blocked. So it'll look like XO, X, XO, X, O, X, O. So now it's a draw. And the value is going to be 0. Okay, so after all this, if nobody wins, and return 0 if the possible moves is empty. Okay, so that passes. Now we're done with the base case. Now we have to handle the recursive case, and we can do that by just being one step away from a base case, and in this case it's one move away from a win. And we'll give it a little penalty here so that if you're one move away, it'll be we subtract 1. Right. Okay. All right, let's write the recursive part. So we start off with a list of possible moves, and we're going to map it to the minimax of its children. And we can do that by making the move and finding the minimax. And this will find the minimax value of its children, and we just need to find the max of it. Okay, we're almost there. We have 100, but it's expecting 99, so we need to give it the penalty, which is we subtract the depth, and we can specify the depth defaulted to 1, and it'll be subtracted. And for all its children, we increment the depth by 1. Okay, so instead of having 2 errors, now we have 1 error. And that's because we didn't handle the case for O. When it's O's turn, instead of doing max, we need to do a min. So let me just wrap this up so that we have a little bit more room to write the code. This code is the same as this. If I say send max, so if I save, you can see we're in the same situation. So we could send a different message to this object. We can say based on the turn. So if it's X's turn, we want to send the max. Otherwise, let's send the min. And as for the penalty, if it's X's turn, then we subtract the depth. Otherwise, we add the depth. Okay, so it passes and everything else passes. There's one more thing that we want to do with Minimax. That is with the timing. Because if we do, let me set a timeout of 5 seconds for a new position. Let's try to run the Minimax. And expect this to actually not to raise error. Because if it times out, it'll raise an exception. So we save, and it stalls here for 5 seconds, and it times out. Okay, and if you scroll to the top here, the error is a timeout exception. So it actually takes about 45 seconds for this to run. That's way too long. The reason why is because it's recalculating a lot of information. Actually, we could get this down to 2 seconds. So I'll just change it to 2 seconds for the timeout. Okay, and the way we do this is by using memoization. And we need to create a class variable here because we have many different positions. Each time you make a move, it's a new position. So it has to share the cache. So let's call it Minimax. And it's based on the board. Actually, let's initialize it first. So if it's not initialized, let's initialize it. And let's get the value. Minimax of the based on the board. So let's return the value if it exists, which is what that says. And if it doesn't exist, we'll calculate it and we'll store it into the cache based on the board. And this assignment statement will return that value we just stored it. So now it runs in less than 2 seconds. We run it again and it'll run the whole suite and everything passes. So now we have it cached and it's running pretty quickly. And so our last method for this is best move. So there are actually 2 cases. We can probably just copy it from here because it's very similar. And we just need to change this to best move. And the best move is 2 in this case and 2 also in this case. So we save. The function doesn't exist, so it fails. And create a function, best move. Okay, we start off with the possible moves, and there's a function called max by. Okay, so given the index, we're going to find whichever possible move is the max based on the minimax value. So let's make the move and find the minimax value. Okay, we save, and we see that the first test passed, but the second one didn't because we didn't handle the case for O. So let's do that for this. We'll send it based on the turn. It's going to be the max by, otherwise the min by. Okay, so it passes and the whole suite passes, which is good. So now we can close this off and we can start handling the user interface. For the user interface, I'm going to set this up so that after it saves, it's going to run the game RB file. Okay, so let's go into the lib game RB and start with the Gosu. Okay, so it is derived from Gosu window. And the super takes a width and a height dimension. So we'll just call it width for now, and both width, and set the width to be 600. Let's see, say width. And the third parameter is whether or not you want it full screen. We don't really want it full screen, so we just say false. Okay, so let's actually open up this window. We can say game is equal to game.new and show it. Okay, so it shows up. There are a couple of problems. One problem is that when my mouse hovers over the window, it disappears, and we want to keep the cursor. Second is there's no way to quit out of this except to kill the window. So let's handle both those conditions. So first, we'll handle button down, and case it takes in an ID. Okay, so case ID, when it's the keyboard Q, when I press Q, then I want it to close. It'll close the window. And so let's see if that works. So if I press Q, it quits. That's great. The next problem is with the mouse cursor. And for reference, okay, this is a quick way to just go to the Gosu library. And it's actually, the file that I need is actually in a different directory. It's under reference. Okay, so this is where all the keys are defined and everything else. So using tag bar, you can have a better view of this. And under window, this is where I knew about button down. We also want to overload needs cursor. So let's go back. Okay, and we'll set this to be true. So let's see. So you can see that now when my mouse hovers over it, it still stays. Okay, so let's draw some lines. So under the draw command, okay, so draw is called every time it needs to refresh. So let's draw a grid. So we'll draw a line. Starting from, and let's define the cell width. Cell width is equal to width divided by 3, and cell width. Okay, so when we're drawing a line, we want the X position to be, let's just say cell width for now, W, and starts from 0 and goes, starts from W and goes to the width. Okay, but the third argument is actually the color, and we just want to use white, so we'll just say Gosu color white. And same thing here, Gosu color white. Okay, so let's end, and let's see, and we see a line. So let's make another one. So cell and cell width times 2. Okay, so we have 2 vertical lines. We can also create horizontal lines just by duplicating this code and just swapping this around. Okay, so now we have a grid, and what we want to do is when we click on a square, we want the X or an O to appear. We want to make a move, so when I click here, it'll make a move. So in order to do that, we need to have a position. So let's start by having a position, creating a new position here. And on the button down, let's see, for the mouse click, it would be MS left for the left mouse button click. When this happens, then we want to update the position. So okay, we want to move, and we want to convert there's a mouse X and a mouse Y. So the mouse X, if we divide it by the cell width, okay, we'll get the X part of it between 0 and 2, and we convert it into an integer. Then we get the Y part. We have to multiply by 3 divided by the cell width and convert that into an integer, because this only works if you're doing integer arithmetic. Okay, so this should mark the position, and we need a way to display it, and we can do that by going through each of the positions on the board. So let me just put a comment here saying draw grid, and this part is draw position. I suppose I could have made this into another function. Okay, so actually what we want to do is we want to display a string, and in order to do that we need a font. So we need to create a font. Gosu font new, and it takes 3 parameters. First one is the window, so we throw in the self. Then we have the font name, and we'll just do the default. So default font name. And the last parameter is whether is the height. So let it be the cell width. Okay. So we have the font set up so we could actually display it now. So we need to go through each of those positions. So given the position and the board, each with index. And that'll give us the piece and the index. Okay, so we only want to do this if it's not empty. So if the piece is not the empty square, dash. Okay, we're going to draw the font. So the font, draw. Okay, the P is the text. And we're going to specify an XY position here. And we don't have a Z index position, so we'll just say 0 for now. Okay, so let's calculate what the X should be. So the X position should be, so we have the index position I, and we multiply it by the cell width. Actually, it's not just I, it's I, the remainder after you divide by 3. So because this is the column position. And the Y is I div 3 times the cell width. Okay, and let's just see what this looks like. Unless, oh, that's because we need to include position, and we get that from the lib. Okay, unexpected argument 0 of type window. Okay. Oh, for the font. Okay. So font.new, it didn't like this self. Let's see, line 11. So that's line 11, and it says expected argument of type Gosu window, but got game. Okay. Okay, this is very interesting because self should be Gosu window. It's an initialize. Oh, the reason why is because self is not set up. It has to be done after the super. Okay, so when I click, okay, this looks good, but the problem is that it's not centered. So let's center it. Okay, so we have the X position here, but we want to subtract the text width of P divided by 2. And well, actually this thing should be going over here, and then we subtract it. We subtract half the width. So now when we, okay, undefined method text, oh, that's because it's supposed to be text width. Okay, so we're off by a lot. Because this actually, we need to add it, not subtract it. Okay. Okay, there we go. All right, so it looks good right now. So after the person makes a move, actually it's over here. So after they make a move, we want the computer to make a move. So we can have an if condition here saying that if the if the possible moves, well, if it's not empty, then we want the computer to make a move. So position is equal to position dot, well, this best move would return an index. And so we need to, actually, let's just put that into the index, and then say at position is equal to position, actually at position dot move based on the index. Okay, so let's see. So when I make a move, the computer makes a move. The computer makes a move, it blocks me, and we're able to play. The last thing that we want to do is throw a message up when the game is over. So this is the drawn position. This draws the position, but then let's put another thing here where it displays a message. And it only displays a message if, let's say, display message U1 if X wins, and you display a message computer 1 if O wins, and display a message draw if the possible moves it's empty. Okay. All right. So let's write display message. So def display message with the text, and what this will do is it'll draw a quad, which is a big rectangle, a four-sided square, well, four-sided polygon, and it takes in X, Y, and a color, and it takes four of these sets. So this is so that we can have a little window to display our message. So let's just put this going across from X is 0 through, I'm just going to hard code this for now and have the background be black. So black is going to be black. Okay, so let's just let it run all the way across. So it goes from this to all the way to the end, so width and 100 black, and then let's say it's 500 black and 500 black. So this will create a big black region where we can display our message, and now we can display our message. But the font is going to be a little bit too big, so I'm going to create another font actually. So let's go all the way to the top here, and I'm going to create a M font for our messages. So instead of it being cell width, let's make it about half the size of the cell width. That makes it a little bit smaller. Okay, so this M font, draw the text, and let's put it right in the center. So the X position is going to be the width divided by 2, and we subtract the so this is in the center, and then we also subtract the text width. Text width, and we divide it by 2. Since we're dividing by 2 for both of these, I'm going to just group them together here like this. Okay, so this takes care of the X position, and as for the Y position, I'll just say it is the width divided by 2 minus, and I think the height I said was well, let's just say subtract 100 from it. I think that's the text width. So let's see if, okay, wrong number of argument 3 for 4. So there's one more. Actually, there is a Z argument, so let's put a 0 there. Okay, so now we have the message. Okay, so let's make the font a little bit smaller and okay. Okay, so divide by 3. Okay, so this is Tic Tac Toe in Ruby using Gosu as the user interface.